Problem 4. Integral of x cubed minus 2 over x squared minus 4 dx. And this is a little tricky one. Might be tempting to just say, well, x plus 2 times x minus 2 are the factors of x squared minus 4. So let's just do a over x plus 2 plus b over x minus 2. But there's a problem with this. And that problem is related to what's called improper fractions. Now, improper fractions are fractions that can be divided out. Like 3 over 2, you can divide 2 into 3 and get 1.5. And of course, 3 over 3, we certainly want to get 1 out of that. Likewise, if I take x cubed over x squared, which is part of the problem up above, I could simplify it to get x. So whenever I have this situation, I have to do something different. And that would be to do a long division. So I have x squared minus 4 divided into x cubed minus 2. And this is an algorithm where the first step is to say, well, let's make a guess. And that would be, what letter or number do I put up top that when I multiply it by x squared minus 4, I'll get a match for the x cubed. And that, of course, is just x. Next step in the process is to multiply. So x times x squared is x cubed. We need to make sure that we multiply that x times the minus 4 to get minus 4x. We put that down underneath. Then we subtract. X cubed minus x cubed is nothing. Now we have to realize that there's a 0x up top minus that minus 4x, which gives us plus 4x. And we just bring down that negative 2. So we find out by long division that x cubed minus 2 over x squared minus 4 is the same as x plus the fraction 4x minus 2 over x squared minus 4. So now we can take the integral of x cubed minus 2 over x squared minus 4 dx and separate it into two distinct integrals. The integral of an x, that was our whole number part of that division, plus an integral of 4x minus 2 over x squared minus 4. And we just integrate x to get x squared over 2, so that's pretty easily done. But then we have to go through the process of partial fractions again. 4x minus 2 over x plus 2x minus 2, the factors, can separate into two fractions, a over x plus 2 plus b over x minus 2. We multiply by the common denominator. On the left, x plus 2, x minus 2, and on the right as well, x plus 2, x minus 2. So we complete our cancellation process. Multiplying the left by x plus 2, x minus 2 gets rid of that denominator. That always happens. And we get 4x minus 2. On the right, we cross out the x plus 2's, which leaves a with x minus 2. And crossing out the x minus 2's, we're left with b times x plus 2. So 4x minus 2 must equal a times the quantity of x minus 2 plus b times the quantity of x plus 2. So making sure that we are bringing along the x squared over 2, we are now going to take that 4x minus 2 is equal to a parentheses x minus 2 plus b parentheses x plus 2 and find our values for a and b. So our convenient value would be x is equal to 2. We do our replacement. 6 is equal to a times now 0, because 2 minus 2 is 0, plus b times 2 plus 2 is 4. And we get 4b is 6, and b is 3/2. The other convenient value, x is equal to negative 2. We plug that in. We get negative 10 is equal to a times negative 4 plus b times 0. And we simplify all that, solve it, and we get a is equal to 5/2. Bringing along the x squared over 2, we now have to solve the other two small integrals, the integral of 5/2 over x plus 2 dx, plus the integral of 3/2 over x minus 2 dx. We have two different u's. u1 is x plus 2, and du1 is dx. u2 is x minus 2, du2 is also dx. And so we have two integrals, 5/2, 1 over u1 du1, plus 3/2, integral of 1 over u2 du2, both being natural logs. So we get 5/2, natural log of the absolute value of u1, plus 3/2, natural log of the absolute value of u2. Back subbing, bring along that x squared over 2, hopefully. We have plus 5/2, natural log of the absolute value of x plus 2, plus 3/2, natural log of x minus 2, plus c.